Okay, complex structures. We'll go over complex structures, talk about what it is and what you need to do for it, all that fun stuff. As always, the questions on a tutorial, I will typically not answer them unless I think it is beneficial for you. And the videos and stuff, you can watch this on your own. All right, so let's get into this. Where are we? So let's look at this real quick though. So the sodium oxide, here's the chemical, like the formula for it, what it looks like. Calcium chloride, here's what that looks like. Potassium sulfide. Use the periodic table. We have our lovely periodic table again. I've showed you this one before, where you can click on an element and learn all kinds of fun things about that element. There's even a podcast too. I discovered this recently all the way down here. You can listen to a podcast that talks about the elements, and it provides you a lot of cool information about them. Okay. Video, we'll skip that. Polyatomic ions, we'll go over this and what that means. So it says simple binary compounds are formed from two elements, and whether the compound is ionic or covalent, its chemical name is a two-word combination. So like carbon monoxide, carbon dioxide, something along those lines. The second name usually is ending in like IED or something along those lines. That's why you see sodium chloride, carbon monoxide, carbon dioxide. All right, so polyatomic ion, a covalently bonded group of atoms that has a positive or negative charge. So it can have either or. Monoatomic ion, individual atom with a positive or negative charge. Again, it can have either or, but it's an individual atom. Okay, periodic table. Again, that's our periodic table. Oops, let's get back to this right here. It's showing you different examples of bonding and what happens. So this is a double bond and a single bond right here. Pretty interesting. Questions. So this question here, you would have to draw out the chemical compound and draw out, okay, it has a polyatomic ion, consists of one nitrogen atom, 4 hydrogen atoms. You'd have to draw that out. So actually, let me hit submit and you can see it's actually at the bottom. Here's kind of what it would look like. So an N, the nitrogen, and then the 4 hydrogen around it with a positive charge right here. Okay, here's some more examples, formulas of polyatomic ions and what we have going on with those. Okay. Investigating polyatomic ions. These questions, I will have you do these on your own. But quickly, I will tell you this one. So study the ions that contain the element chlorine. Similarities between the formulas for these ions. They all contain oxygen, and they have a charge of 1 negative, or -1. All right, so a 2 charge. So here's an example of some negative charges with the 2 negative charge here. And here's the different chemical names, formula, what it looks like. Fun stuff. The -1 charge here, chemical name, chemical formula, all that fun stuff. Here's what it looks like. We'll X out of these. Okay. I'll have you do these questions on your own as well. Compounds of transition metal. Those would be the metals on the periodic table. We have the transition metals. Transition metals are a group that occur. So as you can see, there's the ones that are like right in the middle or like right here, these blue ones, transition metals. This group right in here. Okay. So now it shows main groups, transition, and inner transition. This, the inner transition is just on the bottom like this because otherwise it would be really stretched out and tough to fit on one page. So they kind of move the periodic table around like this. Oxidation state, let's review this definition. Positive or negative number that indicates the number of electrons lost by an atom, assuming the bonds are all like ionic. Okay. Roman numerals, review what number Roman numerals are. So let's see, we have Roman numerals. So like the I, for an example, would be like 1. The 2 I's would be like 2. So you see Roman numerals a lot located on the periodic table. And then the one IV would stand for 5, V would stand for 4, V would stand for 5. Okay, and then we have some other examples here. D sublevel. So this is just showing the sublevel. This shows you the electrons in the outermost layer of the valence shell electrons, how many they can hold. The D block is sublevel is here. More examples. Metal compound. All right, I'll leave that one up to you. And I'll leave this question up to you as well. More examples of polyatomic ions. Kind of the same thing with the question here, but I'll just show you what you're doing is just matching the cobalt sulfide with its correct like formula and what it looks like. Okay. Kind of the same process, and hopefully that gives you just a little bit better understanding, and hope you enjoyed.